Well, this is Lance's metal clock, and for those of you who have been looking at YouTube and clock construction, some of you may have seen my other wooden clock that I constructed a couple of years ago. If you're looking under YouTube, look under Lance's wooden clock and you'll find that, and you can see that it is still working strongly. This clock I picked up at a garage sale, and I didn't realise the importance of it in terms of clock history when I first purchased it. It had been lovingly looked after by a family for over 100 years, and while it was tarnished, the brass, and while it wasn't working and had to be restored, basically all of the components were in really good condition. As far as I know, it was built in the late 1800s by a precision engineer by the name of Mr. Fletcher, and he's been handed down to the various members of the family over the years. I was very fortunate to become the caretaker of this clock, and I believe that by looking at it that probably the mechanism was purchased and then the frame was actually made by this engineer who's done a fantastic job in doing it. The whole idea of this skeleton fusee clock was invented probably around about the 1400s, and the very first clock to have this mechanism was built in about 1430, and even Leonardo da Vinci shows pictures in his drawings, especially one that looked like a helicopter, of a fusee mechanism. So what exactly is a fusee mechanism? Well, you can see the fusee mechanism here, which is a cone-shaped pulley with a helical groove around it. And wrapped around that is in this case, a brass type cord that often used in grandfather clocks, and that attaches to the mainspring, so that as you wind it up and you put the key into the end of that cone, there's a slot there for it, then it tensions the mainspring, and that provides a fairly even base power to the clock. Now, when I got the clock, there were a few problems, and one of those was actually in the main drive shaft that drives the hands, and you can see that it's the first gear that comes off the fusee mechanism. So we would call that, I guess, the first of the main cogs, possibly the great wheel, or the equivalent of the great wheel on a clock, and that was binding with the metal frame. I think somewhere along the line the metal frame had a slight bend in it, or some sort of warping, and I didn't want to risk ruining the clock by trying to get the warp out, so I managed to drill out the frame a little bit, and that allowed the wheel to spin freely. There was also a problem with the actual gears that drive the minute hand and the hour hand on the outside part of the clock, and one of those cogs had to be realigned, and luckily there was enough room on the frame to re-drill the hole, and that worked okay, and the hands now move satisfactorily. You can see the escapement here. It is a pretty standard type of escapement. One of the problems again with the clock was that some of these teeth had been bent, and when I straightened them, luckily none of them broke, and that's working quite effectively now. The other area that it had suffered a little bit over time was the dial, and the numbers had to be put back onto the dial, and the red dots that you can see there also had to be repainted, as were the hands. But overall, the whole condition of the brass is very, very good. There were two parts of the clock missing when I got it, very, very small parts, and it's not surprising over 100 years that these could be misplaced. The first one was the rod that you can see that goes across from the bell to the striking hammer, and that striking hammer has to sit just fractionally off the bell, so you'll get the ringing sound, and that rest was missing, but that was easy enough to make and put into place. The other piece that was missing was further down on the clock, and it sits also attached to the striking arm as a little lever that actually works off the hour hand, off the hour gear, and that is necessary to make the thing ring on the hour, and it just gives one bell ring when that happens. Just to give you an idea of the sort of sound that this clock makes when it does ring, and when I reinstall that arm that's missing, this is the sound you'll get. Now, to move back onto the fusee, I'll go and get the key, and we'll see what happens when I wind that up. As I said earlier, one of the features of this Fuse skeleton clock is the cone with the groove in it, and as you can see where I'm winding it now, and it's taking the cable back off the mainspring drum and winding it round this groove, and as it does, it's tensioning the spring inside that barrel. Now it works that with such a much smaller diameter of the cone at this stage, and because the spring then is much more powerful with the amount of tension in it, that maintains a strong drive to the escape wheel. As the clock runs down and that cable winds back onto the drum, when you get up to near the end of the cone where it's much greater diameter, the spring is well wound down, so there's not as much tension in it, but because of the bigger diameter of the cone, it maintains that same type of pressure for the on the mechanism for the clock to work satisfactorily and not lose time. Now the Fuse cone that we can see here is actually not a pure cone as you would imagine. It is a hyperboloid. Now for the enthusiasts, that really was discovered I guess by trial and error, and it was necessary to make sure that whatever the design was, that it maintained that power to the clock, and having different diameters as the groove progresses obviously maintains that power until you get to that wider groove near the cog. So I think you'd agree when you look at the original photographs that there has been quite a transformation with this clock, and I'm very pleased with the result. I hope you enjoyed watching this and as much as I did in restoring it.